Hello and welcome to today's lesson. Today we're going to be talking about ratios, proportions, and averages. So let's get started. So first, we're going to talk about ratios. And now a ratio says how much of one thing there is compared to another thing. So, ratios can also be shown in different ways. We can use a colon to separate them, or we can show them as a fraction, or we can discuss them. So let's say, first off, that I have 3 apples. So these are my apples. So I have 3 apples. But I only have 2 blueberries. We'll say these are. That means that my proportion of apples to blueberries can be shown as 3 apples to 2 blueberries, or we could say 3 apples, 2 blueberries, or I can just say 3, 2, 2. So there's 3 different ways to write that. Another example here is if we have the ratio 3, 1, I can also write this as 3 over 1, or I can write it as 3, 2, 1. Okay, we can also scale up a ratio, which is kind of like reducing a fraction but working backwards. So again, if I have a ratio of 3 to 1, I can actually times this by 2 and get the ratio of 6 to 2. And these are equivalent. So they mean the same thing. Because if I were to reduce this, it is the same as saying 3 to 1. So the trick is to always multiply or divide the numbers by the same value. So for example, if I take 4 to 5, that is actually going to be the same as 4 times 2 to 5 times 2, which ends up giving us 8 to 10. Okay, another example is if I have 3 cups of flour and 2 cups of milk in a recipe. So our ratio of flour to milk is then going to be 3 to 2, just like the apples and blueberries. But let's say for this recipe there's a ton of people, so we need to have 3 times the quantity of our recipe. We can keep the ratio the same by multiplying both sides by 3 to get a similar ratio of 9 to 6. And here again, the ratio is still the same between these two. So now we can have some examples of part-to-part ratios. So let's say we have 5 dogs. Okay. So there's 1, 2, 3, 4, and 5. 5 dogs. Now, let's say that there are 3 boys. So these are going to be my boys. And there are 2 girls. Okay, so then my ratio of boys to girls, we're just going to go boys to girls, is 3 boys to 2 girls. My ratio of girls to boys, 2 girls to 3 boys. Now if we want to compare the parts to the whole, we can take the ratio of boys to all dogs, which is, well, there's still only 3 boys, but there are 1, 2, 3, 4, 5 dogs, so it's 3 to 5 as a ratio. And if I want the ratio of girls to all, that is 2 girls to 5 dogs. So that again is comparing our parts to the whole. Instead of over here, we're comparing parts to parts. Parts to parts. And down here we are parts to whole. Okay? So now we're going to discuss aviation applications to ratios. So there's a couple of terms we first need to learn, because ratios do have such a wide range of applications within the field of aviation. So first, there's something called the compression ratio. And this is, on a reciprocating engine, is the ratio of a volume of a cylinder with the piston at the bottom of its stroke to the volume of a cylinder with the piston at the top of its stroke. So to simplify this, I'm going to write piston volume at bottom. This is 2 piston volume at top. So, I'm going to quickly highlight this. So this, an example here, would be a typical expression ratio such as 8 to 2. Or we can also say 8 to 2. Okay, so it's just a regular ratio. It's just describing the piston volume at the bottom to the piston volume at the top. The next term we need to learn is the aspect ratio. And this is when the ratio of the length of an airfoil to its width. Okay, so length of airfoil to width of an airfoil. And again, an example here is just a typical expression ratio for a commercial airliner, and that could be 7:1. Notice again, this is the same as the ratios we've discussed before. It's just describing the length to the width of an airfoil. The next term we need to learn is the air-to-fuel ratio. Air-fuel ratio. Now, this is a ratio of the weight of the air, weight of air, to the weight of the fuel. Weight of fuel in the mixture being fed into the cylinders as a reciprocating engine. So again, to reiterate, air-to-fuel ratio is the ratio of the weight of the air to the weight of the fuel in the mixture being fed into the cylinders of a reciprocating engine. So, for example, again, we could end up with something like 12.3 to 1. Again, even though we have a decimal here, it's the same kind of looking ratio. The next term we need to learn is called the glide ratio. And this is the ratio of the forward distance traveled to the vertical distance descended when an aircraft is operating without power. So again, forward distance to vertical distance descended. I'm going to cut a down arrow. And this is in brackets with no power. So without power. Okay? And another example here is a ratio of, well, it's if an aircraft were to descend 300 meters, so 300 meters descent, while it travels through the air for 3 kilometers forward, then its ratio would be 3,000 to 300. Okay, that's changing kilometers into meters, so we're in meters for both of them. The next thing that we need to learn then is something called the gear ratio. And this is the number of teeth each gear represents when the 2 gears in an aircraft component. So if a pinion gear were to have 8 teeth and a spur gear would have 28 teeth, the ratio would be 8 to 28. Okay, so that is, like I said, number of teeth to number of teeth of gears. And again, our example was a pinion gear had 8 teeth and a spur gear has 28 teeth. Then our ratio is 8 to 28, 28, or we can also show this as 2 to 7, and that's just dividing by 4, or reducing. The last thing we need to learn about is the speed ratio. Now, the speed ratio is something that we use when 2 gears in an aircraft component. The rotational speed of each gear is represented as the speed ratio. So, that's a D, speed. This is rotational speed of the gears Now, as the number of teeth in a gear decreases, as teeth decrease, the rotational speed increases. Now, what this means is that the gear ratio the speed ratio is the inverse of the gear ratio. So, for example, if two gears have a gear ratio of 2 to 9, we'll call that our gear ratio, then our speed ratio is going to be 9 to 2. Okay? So we'll get into a couple of examples here. So our first example is we have a pinion gear with 10 teeth, and it is moving a spur gear with 40 teeth. And the spur gear is rotating at 160 revolutions per minute, or RPM. So we want to determine the speed of the pinion gear. So how do we set this up? Well, this is going to be teeth in the pinion gear number over the number of teeth in the spur gear, and that is going to equal speed of the spur gear over speed of the pinion gear. And again, what we're looking for is this one right here, the speed of the pinion gear. We know every other value, so that'll be written as shown. Number of pinion teeth over number of spur teeth is equal to revolutions per minute of the spur over revolutions per minute of the pinion. Now what we're going to do here is something called a cross multiplication. It's going to look like this. We're going to multiply 40 by 160, and we're going to multiply this question mark by 10. It's going to look like 40 times 160 is equal to 10 times our question mark. So then to find the value of the question mark, we take 40 times 160 and we divide it by 10. And that is going to give us an answer of 640 revolutions per minute. In our next example, we have a plane, an airplane, going at a speed of 400 kilometers per hour. Its maximum speed is 500 kilometers per hour. What is the ratio of cruising speed to max speed? Well, that's as simple as that. So it'll be cruising to max, which is really just 400 to 500. And if we were to reduce this, the ratio would be 4 to 5. Okay, our last example here, we're going to express the ratio of 9 to 5 as a ratio with the denominator of 1. Okay, so I have 9 to 5. Grab a different color. 9 to 5, or 9 over 5 as I can write it. And that is equal to something over 1. Okay, so if we use cross multiplication again, then we end up with 9 times 1 is equal to 5 times a question mark, which is just 9 divided by 5 again, and 9 divided by 5 is equal to 1.8. So therefore, if we're going to express 9 to 5 as a ratio with a denominator of 1, we would have to write this as 1.8 over 1, because the 1 as the denominator is not going to affect our numerator. Next, we're going to talk about proportions. Now, proportion says that 2 or more ratios are equal. So, that is like saying 1 over 3 is equal to 2 over 6, right? Because if we were to reduce 2 over 6, we'd end up with 1 over 3. And of course, this means then that 1 to 3 is equal to 2 to 6. So the ratios are the same, which means they are in proportion. So, an example here would be 3 over 5 is equal to 6 over 10. Or, like we said, 3 to 5 is equal to 6 to 10. And we can also read this as 3 is to 4 as 6 is to 10. Okay? So a little bit of a harder example here. Let's say that we have a metal bar and its length and weight are in proportion. Okay? So that would be something like length and weight are in proportion. So when the bar is equal to, or we have 10 meters of bar and it weighs 5 kilograms. So that means that 20 meters of bar weighs 10 kilograms and 80 meters of bar weighs 40 kilograms. And what we can take out of this is 10 to 5 is equal to 80 to 40. It's the same, so they're in proportion. One more example for proportions here. Let's say we have 18 buckets of stones in a mixer. So stones, 18. How much cement and how much sand would you need to make it a 1-2-6 mix? So we want it to be a 1-2-6 mix. Okay, so I have, if I create a table, I have cement, I have sand, and I have stones. So what I need is to have 1 cement, 2 sand, and 6 stones. But what I have is, I don't know, and I don't know, but I have 18 stones. So if we look at 6 and 18, we can realize that 6 times 3 is 18, which would mean that we would have to multiply these by 3, and we'd have to multiply cement by 3. So that would mean 2 times 3 is 6, and 1 times 3 is 3. So our ratio here is 3 to 6 to 18. And that is equivalent to 1 to 2 to 6. Perfect. So now we're going to move on to solving proportions. And with when solving proportions, we will know 3 quantities, and we will have 1 quantity that we don't know. So to solve for this unknown value, again, we're going to cross multiply. So it'd be something like, I have value A over B is equal to question mark over C. And we're going to do the same thing that we did earlier. And we are just going to cross multiply. Okay. And then we're going to divide the value of the divide the value multiplying by the question mark to find the unknown value. So this would be A times C is equal to B times question mark, and then A times C divided by B is equal to question mark. Simple as that. So we're going to go through a couple of examples. So first we're going to solve for x. So we have 60 over 85 is equal to x over 100. Okay, so then again cross multiply. Maybe we'll use colors to see, green and blue. So I have 60 times 100 is equal to 85 times x. Now to solve for x, I need to divide by this 85, which gives me 60 times 100 divided by 85 is equal to x. Okay, and that would have x be 70.59 if we're rounding to 2 decimal places. Our next example here is, what is $12 as a percent of $65? Okay, so we're going to approach this the same way. Going to have $12 over, well, I'm going to get rid of those the decimal because I don't need it, over $65 is equal to some percentage out of 100. Okay? And we're using 100 because if we remember, percentage means parts of 100. So doing something over 100 is going to give us exactly what this percentage is. Exactly what we want. So again, I'm going to cross multiply, and I get 12 times 100 is equal to percent, what I want to know, times 65. So then to get percent, all I need to do is divide by 65. Divide by 65 gives us percent, and percent then is actually equal to 18.46, again rounding to the second decimal place, and this is a percentage, so I'm going to make sure to put that percent sign in. Up here as well, over x over 100, this is a percentage, so make sure we don't forget that. Now our last example of percentage, we have an airplane flying 500 kilometers. So flying 500 kilometers, that's a distance. And it's going to use 35 liters of gas. So how many liters will it need to travel 1,100 kilometers? Now again, so the first thing to identify here is what our ratio is, and our ratio is kilometers to liters. Okay, kilometers to liters. So what that tells us is we're going to have 500 kilometers to 35 liters is equal to 1,100 kilometers, how many we're going to finish with, over some form of liters. Okay, so again, nothing changes here. We're still going to cross multiply even though it's on the bottom. And this time I'm going to end up with 35 times 1,100 is equal to liters times 500. Okay? And again, I want to get L alone, so I'm going to divide by 500. 35 times 1,100 over 500 equals L, and that means that the amount of liters we're going to use is 77 liters. Now the last thing we're going to discuss today is average values. And an average is a single value that describes a list of values.